Today we have a presentation by BiJay Adams. BiJay is the general manager for the Liberty Lake Sewer and Water District. He's responsible for implementing the policies and objectives established by the Board of Commissioners and carrying out the district's mission. As general manager, BiJay is responsible for all aspects of district operations and business management, including but not limited to developing policies, achieving regulatory compliance, comprehensive planning, customer service, intergovernmental and professional relations, and environmental stewardship. So we're excited to see BiJay's presentation. We are going to save all questions to the end. Unless there's something that I feel is really clarifying that we need to ask in the moment, I can interrupt him and ask that. But we'll save most of the questions to the end, but you can type them in anytime. There's a Q&A box at the bottom of your screen, so you can type in questions there at any time, and we can ask those towards the end. So BiJay, are you ready?
All right. Well, thank you for having me along today. I will be presenting on landscape irrigation efficiency on behalf of the Idaho-Washington Aquifer Collaborative. Currently, I am the vice president of IWAC. We're a consortium of water purveyors and interested agencies and folks who are interested in aquifer preservation and of our valuable resource. So one of those missions of IWAC is to produce education materials, and we have a number of videos out with regards to aquifer protection and some methods and that we're happy to share with people. And one of the videos we recently did was on landscape irrigation efficiency and retrofit. So you can find a video out there on that, but there's also a number of videos on backflow protection and things like that. So encourage you to visit IWAC's website, but today we'll talk about landscape irrigation efficiency. So a little bit of background. As you may know, landscape irrigation is the single largest use of potable water in the United States. In fact, about 70% of that use is outdoors annually. And it's as much as 50% of that water used for irrigation is wasted due to evaporation, wind, overwatering caused by inefficient irrigation methods and systems, which I'll highlight those today. So it's believed through education planning, you can estimate that landscapes can be well maintained using 30–50% of water, and we'll provide a pilot example of how that could be achieved. So the biggest issue is landscape irrigation lacks national or international standards for construction and installation. And a good comparison would be with thinking of plumbing standards or electrical codes, those kind of things. There are no codes or standards for landscape irrigation systems. And most of these systems are installed by seasonal employees with little or no knowledge or non-certified individuals. And also couple that with jurisdictions do not have strong provisions for efficiency within their codes or requirements for construction standards. So the combination of those two really creates this environment where you have design standards that or irrigation systems that are designed to be not very efficient. So what I've done is used Google Earth to kind of comb over the Spokane Valley Rathdrum Prairie Aquifer starting from Idaho up in Athol. And I look primarily at public landscapes. Their larger landscapes is more observable, but it does occur in smaller landscapes and residential lawns. But I've just went through a lot of public areas from Idaho and into Washington. So I'd like to highlight those here, starting with Athol Elementary in Athol, Idaho. You can see, I'll actually use a laser pointer. We have a number of these very green donuts. And ideally, you want to have heads that spray head to head to minimize these green donuts with dry spots in between them. So typically what you see is landscape managers will water to these dry spots. So if your heads or your system is incapable of watering to these dry spots, it does not matter how much you turn up the clock timer, it is always going to be dry and brown. So you can see a number of dry spots and green donuts within Athol Elementary School's landscape. Betty Kiefer Elementary School in Rathdrum, a lot of the same things there. However, you can see other unique features, like up in this top corner up here, where you might have a broken head that's creating these irregular features, and then very green donuts of various sizes. And there's some parts of landscape that are pretty good, and some parts of landscape that are much drier and more presence of green donuts. Next one, Dalton Elementary and Dalton Gardens. Same kind of thing. You'll see a lot more dry spots in some of the ball field area. Some areas that are pretty good, but a lot of green and brown areas and green donuts. Woodland Middle School. It's got a lot of the same stuff. It's very good down on the southern portion of the landscape. Got good distribution uniformity, and I'll get into what that term means in a future slide. But you see a number of dry spots there and irregular patterns. Highlands Golf Course in Post Falls. This one has a lot of very unique patterns with it. Hard to know if that's slope drainage or if it's broken heads. But these are the type of things you want to be looking for. And on the ground, it looks quite different than when you're looking at it from aerial photography. Spokane County Sheriff's Training Center in Newman Lake. You have some areas that are completely brown and devoid of irrigation. Some areas that are very, very uniform, and then green donuts throughout that landscape as well. Liberty Lake Elementary School in Liberty Lake, a lot of the same patterns there. Valley Christian School in Spokane Valley. You can see that this landscape recently was watered by evidence of the baseball diamond. You can see it's kind of very wet inside the diamond on both of those, in fact. Whitman Elementary School in Spokane. Not sure what's going on with this property. You see portions of the kind of the southwest corner, very uniform and solid green, some green donuts to the upper right hand corner, and then some areas of the landscape that are completely dry, almost as if those irrigation zones are turned off or inoperable. So I'd like to kind of highlight some of the design inefficiencies that we see out there. The text highlighted in yellow are the ones I'd like to kind of spend the most time on. We just talked a little briefly about proper head spacing, which is distance. You ideally want those spray heads to spray head to head, so you minimize the amount of brown spots in the green donuts. And then also be considerate of what's going to block it, a flagpole, a fence, those kind of things that are going to contribute to that spray pattern not reaching its designated area. Proper head applications. So you obviously want to put a head in if you need to achieve a 6-foot spray space. You don't want to put a head in that sprays 15 feet. We see this pretty commonly with the residential areas where they have a broken pop-up spray head and they just go to Home Depot and, well, this looks like it, and just buys it, but they don't recognize that that head actually sprays 15 feet when you only really intend it to spray 6. So that extra water is a waste. Also, you want proper nozzle applications, fine mist, large droplets, and breakup to make sure you don't want to just spray a steady stream. You want to have proper breakup so it actually will get water sprinkled throughout that whole arc or radius of the spray head where it's broke up, and otherwise it's just steady streams and you're just going to create those donuts. Mismatch heads is another thing. If you have a landscape that's all rainbird, for instance, you want to stay with the same type of rainbird head. You don't want to put a rainbird head and then a toro head and a hunter head all within the same zone, because you'll end up having mismatched heads and they're not going to achieve their proper efficiencies. Zone separation is another important thing. You don't want drip irrigation being on a spray zone. You don't want spray zones being on a rotor zone, that kind of thing. So you want to make sure you break up your zones, because those have different precip rates based on spray zones, rotors, or definitely based on drip irrigation. System pressure is another biggie that people often overlook. That was something that we encountered at our office. Was we had too high of system pressure. So when that zone turned on, all it did is a lot of misting, and we didn't get water out there. And all similarly would happen if you had low pressure. The spray heads aren't going to be able to spray as far as their intended purpose, which might contribute to some of those green donuts either way. Soil type, compacted soils, root zone depth are all important. As you probably well know, in our area, the home builders like to strip topsoil and sell the topsoil when they're making a development and leave the homeowners with very little topsoil, if any, and they're left with the valley gravels beneath. So, they're kind of stripped of all of the essential topsoil that they need. So soil type's very important. Could be a lot of sand, could be a lot of rock, that sort of thing. So maintenance inefficiencies, these are kind of more on the homeowner side. You want to make sure you have your heads, properly tilted. You don't want them spraying directly down or too high in the air. That'll contribute to these green donuts. And then we encourage nighttime watering, which is great. However, with nighttime watering is you don't get to see your system run that often, right? And so you might not recognize that you have broken heads or heads that have been hit by the lawnmower or out of alignment. So it's important if you're watering at nighttime to check your system regularly to catch those broken areas before typically people just find them when that area becomes dry. System operation inefficiencies. This is a little bit more on the homeowner side as well. Scheduling, you want to do your startup and shutdown times and your run times. We really encourage cycle soak programs where if you want to achieve, let's say 30 minutes on zone 1 of your sprinkler system, you might consider breaking that into 3 different run times to where you're going to give it 10 minutes each run time. So 10 minutes at 2 a.m., 10 minutes at 4 a.m. and 10 minutes at 6 a.m., that kind of thing. As well, it'll allow it to do is water will hit the landscape, soil, soak into the soil, allow the plant to uptake that rather than just spray it all at 30 minutes. Then you're going to end up getting, all the water below the root zone depth is wasted water, or you're going to cause it to run off the landscape. Leaving grass clippings on the lawn is very important. It actually substitutes as a fertilization. So that's all not a popular thing to do, but you can mulch or keep grass clippings on there, and that's one less fertilization you have to do. Sounds funny, but new turf settings, there's a number of times that we've been in contact with our customers that complain about how much water they're using. So we go out and take a look at their site and observe that their house is 3 years old and they still have the irrigation timer set for new turf running 3 or 4 times a day. So it's important to recognize that, homeowners may not know if their clock timers need to be adjusted. And then we also promote sensor technologies. There's a lot of great sensor technologies out there for irrigation systems. These could include soil moisture sensors, they could include rain sensors, and becoming even more popular and affordable these days is mini MET stations or meteorological stations that are on and plugged into irrigation systems. So just kind of go through some pictures of some of these inefficiencies that we see. We're not trying to grow grass in the street. Properly adjusting these heads is important for water conservation and efficient landscape irrigation. Recognizing when and how long your run times are in operation, or you don't want it to run where it's trying to water through 3 inches of water in the bottom of the swale. Runoff. So this would be a great example of one of those situations where you would want to do a cycle soak program where you're not running that zone for too long, causing that soil to become saturated and run off across impervious surfaces. Here's another great example of a new residential construction in Liberty Lake in 2006 where presumably maybe they had new turf settings, but Still not appropriate, where they contributed a lot of offsite runoff, got down into the street and carried it down the gutter. Broken heads, you see these a lot of times on these little islands in parking lots. Broken head that just puts out an immense volume of water, runs across the entire parking lot before it eventually makes its way into a storm drain or lake or river or stormwater swale, picking up pollutants along the way. So this is a little graph I'd like to explain about plant water requirements and irrigation scheduling. So this graph really goes from March to October, and that's intended to depict when we turn on sprinkler systems, which typically turn them on in, well, I would say even later than March, but a lot of homeowners will turn them on when the weather starts getting better, after, right around March, April timeframe. And then we'll, depending on the year, turn them off in the September, October timeframe. So the typical behavior for irrigation systems is you turn them on and you leave them at the max setting that you would achieve in, the highest setting in like July, because that's the hottest part of the year when you have the driest conditions on your landscape. And then you turn it off in October. So you're essentially watering in a box. Reality is, grass or any type of plant you're watering, the plant water requirements are more along the lines of a bell curve, highlighted in green. So, the plant water requirements in March and October are much less than they are in July at the peak. So this data came from our, we have a little met station in Liberty Lake, and we pulled some data from 2020 and kind of evapotranspiration rates for grass in inches, from March to October. But if you turn your sprinkler system on in March and you turn it off in October and you're watering to July, all that area in blue is your area where you can achieve water savings. So most people turn it on in March, turn it off in October, and they water in a box from at that peak in July. So this blue is intended to show where you would achieve most of your water savings. You're never going to achieve a lot of water savings in July. That's just reality. But if you're trying to follow more along the lines of that plant water requirements and that bell curve, that's where you're going to achieve most of your water savings. I had briefly mentioned this concept of distribution uniformity, and what distribution uniformity, just think of it like a percentage, like a grade in a way. If you have a landscape that is 100% efficient and you want to put 1 inch of water on that landscape, you're going to get 1 inch of water on the landscape. But most systems that we find are 50% or less efficient, or have a distribution uniformity of 50%. So that's kind of like an efficiency. So if you want to put 1 inch of water on your landscape and your system is only 50% efficient, you're actually going to need to apply 2 inches of water to get and keep those areas green. So distribution uniformity is really important, how efficient your irrigation system is and how efficiently you're applying water to the landscape. And distribution uniformity is measured by doing what's called a catch can test, where you place catch cans at or between sprinkler heads. And you can do this with tuna cans, you can do them with Tupperware, whatever. You run the zone for 5 minutes or some duration of time, and then you measure the volume in each of those catch cans. So a system that's 100% efficient is going to have uniformly the same volume in all of those catch cans across the landscape. Well, we realize with wind, with the design inefficiencies we may have on our landscape, proper head spacing, head type, those kind of things, you're never going to get a landscape that's 100% efficient. But there are things that you can do to increase efficiency of your landscapes. This picture is just showing another example of the catch can test on a landscape in Liberty Lake. And if you think about efficiency of the different types of irrigation systems that are out there, subsurface drip, obviously you would be intuitive to think of that as the most efficient because you're getting water directly to the plant. That's 90%. Surface drip irrigation's 85 because there's some loss to evaporation. Large rotors are pretty efficient. You're going to see those in golf courses, and golf courses are very good at being efficient with the water because for playability purposes. Small rotors are 65, and Nemesis spray heads are only 50% efficient. But there's some things that you can do with these spray heads to increase their efficiency, and that is retrofit them to what's called a match precipitation or MP rotator. Match precipitation is really just means the amount of precipitation in a given area is uniform. So if you have a head that's 90 degrees and is putting out 2 gallons, then a head that's 180 degrees is 4 gallons, and a head that's 360 degrees is 8 gallons. So those are all match precipitation heads in that kind of scenario. Hunter, Rainbird, Toro all offer these mini rotators. And to highlight them, a traditional spray head on top is what you would see. They put out a high volume of water in a short amount of time. They're very susceptible to wind drift, and their flows range anywhere from 0.1 to almost 6 gallons per minute. Whereas an MP rotator or any small rotating head, their flow gallons per minute is about 0.17 to 1 gallon per minute. So if you were to imagine if you had, just swapping one of these out from a traditional spray head that is about 2 gallons per minute to an MP rotator that's a half a gallon per minute, you're going to achieve just 73% reduction in that one sprinkler head alone. If you're going to run that for like a 20-minute interval. So if you did that across your landscape, you can save a significant amount of water, and these heads are much more efficient. You do not need to change your run zone times. Another benefit of having these types of heads is across the design. So these mini rotators have the slowest precipitation rate for any pop-up in the industry. And because of this low precip rate or across such a large radius means less pressure loss through the zone. So that means you can put more heads on a single valve, and it simplifies the layout. The simplified layout saves money for the owner and contractor for installing the additional pipe, the fittings, the heads. And then also once they're installed, it saves the homeowner less water or less money and less water. So in a retrofit scenario, it's pretty simple. You could just skip some of these heads and not apply them all. But this is an example of where you would have design using traditional sprays. You can see the number of heads as opposed to a design using some of these match precipitation rotators. So I'm going to provide a little pilot example of what we did at our office at Liberty Lake Sewer and Water District. We have 2.5 acres, just shy of 2.5 acres. I audited our system in June of 2005 and did a catch can test and discovered that our system was only 44% efficient. We implemented a number of landscape measures. I mentioned this previously, we regulated our pressure. We matched all of our heads. We purchased all the same type of head and we aligned them. And we also installed the soil sensor-based technology. The cost of these implements were about $500, which included the most expensive item, which was the soil sensor. The following year, we were able to reduce our water by 36%, and we improved our distribution uniformity to 61%. This image that you can see on this slide is also from Google Earth from 8 of 2011, and this is the same set of all the other Google Earth images that I've shown in previous slides. And you can see our landscape is very uniformly green, absent of green donuts. So the things that we did there definitely had an impact and improved our unit efficiency across our landscape. Another thing we did is we took our swale on the north side of our parking lot, and there were existing 22 pop-up spray heads on that swale. We retrofitted those 22 spray heads to MP 2000 rotators. And each of the spray heads was putting out 2.66 gallons per minute. So when we converted those over, it went to 0.71 gallon per minute per head. So our recognized savings was about 43 gallons per minute every minute the system ran. So that's a significant amount of water savings that can be achieved in just very simple retrofits. Another thing we did is we took our roadside swale, and on that swale we had 61 spray heads. So it goes back to that design where I said that you could skip every other head, and that's exactly what we did. We did not retrofit the 61 spray heads. We only retrofitted 34 of them. Same thing, we converted them from the pop-up spray heads to MP 1000 rotators. So we eliminated 27 of them. And the heads that we retrofitted were producing 1.85 gallons per minute. We were able to reduce that to a half a gallon per minute per head. And so our recognized water savings was about 96 gallons per minute every minute that system ran. So in combination with both swale retrofits that we did and our landscape, we had some significant water savings at our office. So one of the things that IWAC has been working on recently is a landscape design guidelines. And this is a booklet that we put out. It's been modeled after California and Florida's landscape standards. And it's really to provide the industry and local jurisdictions and agencies with an understanding of the importance of efficient landscapes. And then what this standards does is it gives us a tool that these industry or agencies can use to recommend elements in an ordinance or design standard that they can incorporate for irrigation systems to maximize efficiency and to promote some design standards. Because absent of those standards, we're going to continue to have inefficient systems that either from design or just from lack of knowledge and understanding of the proper way to design, build, or retrofit a system to maximize efficiency. So with that, I'm happy to take any questions.
Great, thank you, BiJay. We do have one question. Have you ever worked with clover as a supplement to turf grass due to clover not requiring as much irrigation as well as a barrier to weeds?
No, I haven't. That's an interesting concept, but yeah, I mean, most of what we're dealing with is just traditional turf landscapes and trying to maximize efficiency on traditional turf landscapes. And then also IWAC's guidelines promote the use of native plants in lieu of traditional turf. So I would say that, a clover would fall within that category of, trying to use other types of plant materials to use less water and, similar to like a rain garden style.
Mm-hmm. Yeah, I guess one question I had was, I think this is all really important, but it definitely those Google images of the Google Map images of the lawns made me realize that how much of our society values that green lawn, and how much space is dedicated to that and how much water is dedicated to that too, and maybe the need for some other alternative ground cover that would be less water intensive.
Yeah, absolutely. And that's another thing, of getting past the mindset of, just traditional lawn and turf, and using more and incorporating more, maybe not across your entire landscape, but incorporating more native plant materials and both from a stormwater perspective, water quality perspective, as well as, less water use, more aesthetically pleasing, provide better habitat for birds and bees and those kind of things.
Yeah. Yeah, exactly. So if anybody has questions, let's see. Would use of these efficient devices be helpful in reducing runoff to our water bodies, especially on shoreline properties?
Oh, absolutely. Yeah. Yeah. And in some of those images that I showed runoff, I mean, obviously, where that's going to go, it either goes to a stormwater swale, it goes to, a dry well, which is going to infiltrate directly into the aquifer. It's going to go to any stream, river, or water body. Yeah, so it's very important to use of these efficient devices to reduce the amount of runoff, especially if we're over, you have broken heads or you don't have properly aligned heads, or or just over watering in general.
Right. Yeah. Yeah. And I don't know how many people are, thinking about what happens to that water when it runs off of their land. I think that the concern is their grass, and people don't necessarily realize that it's going into our lakes and rivers and aquifer.
Yeah, and can pick up contaminants along the way.
Yeah, especially, yeah, how often you see the sprinklers spraying into parking lots and roads, as you showed pictures of. It's pretty incredible. We have a question. Can you talk about the impact of summer irrigation on the Spokane River?
Yeah, so there's been some recent studies out about, and I'm worried about this year being a very similar scenario where we had lack of snowpack, lower river flows, lower amount of storage in our watersheds, and perhaps a very dry drought conditions, and our landscapes will be starved for water. And so, yeah, increased pumping has an impact on aquifer levels, and an impact of aquifer levels has an impact on river levels in the Spokane River as well. So they're all, as you may know, they're all interconnected. And you know, increased pumping, especially in, I'm worried about this year being a prime example of that.
Yes, definitely. Kind of in tying into that, given the new watering rule, which is just watering every other day, that came out of Spokane, do you think that they will be able to regulate and enforce that? And do you know if there's any fines associated for non-compliance?
Yeah, I've heard of this. I don't know the details around how they're going to regulate and enforce it, or if there'll be any associated fines. However, I do say human behavior, and not that I don't encourage these types of ordinances to promote, water conservation, but typically what you see is from a homeowner's perspective, they're going to keep watering the same amount. They're just going to change the days in which it waters. So I'm going to water my landscape, you know, 30 minutes on zone one every day. Well, then now they're going to do 60 minutes or something every other day. So it's the same amount of water. You're just going to maybe cause more of an impact on the municipality in meeting those demands. Same thing that kind of happens in, you know, odd even watering, or, watering based on time of day, which I totally promote, and encourage watering at night versus during the day because of evaporation. But from a total amount of water pumped, that it's just a matter of timing. I think the biggest bang for our buck, and I'm very jaded, is that, we need to have our landscapes to be as efficient as possible, because human behavior is they're going to water to the dry spots. And so if you're not getting water to those dry spots because your system is not capable of doing that, and you just keep increasing the runtime, you're never going to be happy with your landscape. So people are going to be encouraged to just water more rather than water less if they see green lawn. So, these things are great, but sometimes they're not effective on, in terms of reducing the amount of water used. It's just moving around between times.
Right. Um, and I mean, that brings up a good point too. If they're watering for double the time every other day, that even lowers the efficiency, as you were talking about. The ground becomes saturated and that water can just run off. Um, do
And
you?
it puts more demand on the water purveyor to meet those demands.
Yeah.
Because I could say as a water purveyor, our biggest demands are when sprinkler systems are running in the summer, right? So it's whether that's at 6 o'clock in the morning or 5 o'clock in the morning or whatever, that's the largest water use and when our wells are working the hardest.
Yeah. Do you know of any regional or local incentives for improving irrigation? It seems like maybe that would be more efficient than these regulations.
Yeah, City Spokane's adopted a Spokanescape where they're providing incentives for removing turf and installing, native drought tolerant plants or converting your landscape into more of that type of landscape. So they're offering some incentives for reducing turf. Um, yeah, I think those are great programs, and I would encourage all, you know, entities to be able to look at how can they could offer those incentives.
Hmm. Yeah, I was just even thinking about the switching out the heads of the sprinklers from the spray to that more efficient style, and if there was any kind of incentive program for that, there'd be an upfront cost for a homeowner, but there'd be a long-term payback for both the homeowner and for the purveyor and for the community and our water supply and things like that.
Exactly. Yeah, we've done some incentives in the past on soil-based sensor technology, where we had a bunch of sensors we were providing to our customers. So yeah, there sometimes those incentive programs are difficult unless there's some monetary value attached to it. They think there's a catch. So it's definitely an education campaign.
Yes, definitely. Well, um, and do you know, so IWAC, you talked a little bit about IWAC at the very beginning. As a group, does IWAC ever implement either these incentive programs or any regulatory programs, or is it just up to the individual entities that are part of that partnership?
Yeah, they produced a guidebook to help agencies and reduce the fact from like wanting to start from scratch or recreating the wheel, to provide a one-stop shop for municipal entities to be able to adopt a portion thereof, or whether they want to just deal with the landscape or whether they want to deal with the irrigation component. They could adopt one or both. So it's really provided as a menu of options for the municipal entity to incorporate into their landscape ordinance.
Great. Good to know. Are there any other questions from our participants? Okay. Well, great. Thank you so much, BiJay. We really appreciate your time and your work with the IWAC. And also, I was impressed that you had gone through and done all these steps at your office, because I think that that's something that, it's one thing to say what people should do, but to actually go through and implement it and actually check your efficiency and improve it and, um, walk the walk. I think that's noteworthy. So thank you for that.
Yeah, it's good information to show and educate.
Yes. All right. Well, thank you everybody for joining. Thank you very much to BiJay.